Chapter 7, Section 4, Exponential Growth and Decay. And we'll also call this separable differential equations. Separable differential equations. When something increases or decreases exponentially, something increases or decreases exponentially, those words equivalent to saying these words: rate of change of the population is directly proportional to the population. So these phrases are what we mean by exponential growth or decay. If something increases or decreases exponentially, same as saying rate of change of population is directly proportional to the population. In symbols, say P is population. The rate of change of population means the derivative of the population with respect to time. That's the rate of change. Is, this word is, means equals. Directly proportional to something means equals a constant times the something. In this case, directly proportional to the population. So this is a very famous differential equation. It's the symbols for the words. Rate of change of population is directly proportional to the population. When we solve this differential equation, I'm not going to go through the process, but you will get an equation that we used in pre-calculus. This is actually the solution to that differential equation, where P sub 0 is the initial population, and P is the population after time t, where the t is in the exponent. And the E is, as usual, 2.718, etc. T is time, as mentioned. And K is called the growth constant or the decay constant. Depending on something is increasing or decreasing, decay is the constant, either the growth constant or the decay constant. So this is actually the solution to that differential equation. We can discuss how we get that at another time, but right now we're going to just do page 361, exercise 24. A colony of bacteria is grown under ideal conditions in a laboratory so that the population increases exponentially. That means P equals P sub 0 e to the kt. That's what grows exponentially means. At the end of 3 hours, time 3 hours, there are 10,000 bacteria. So the population of bacteria is 10,000. At the end of 3 hours, 10,000. At the end of 5 hours, 5 is time, there are 40,000 bacteria. How many bacteria were present initially? So we're just going to do a lot of plugging in and solving. There's really no calculus here. It's algebra. The P can be replaced with either of these. I'll use the 10,000. The P sub 0 is unknown. We don't know the population at time 0. E is E. The K we don't know, but we do know that the population is 10,000 when T is 3. So there's two things we don't know in this equation. So now I'm going to replace the P with 40,000. Let's say P sub 0, still don't know it. E to the 5K, because the time it takes, it's 5 hours. That's how much time it takes for the population to be 40,000. So this equation also has two unknowns, same unknowns. So we have what's called a system of equations. We could solve either equation, eeny, meeny, miny, mo, for either unknown, P sub 0 or K, and whatever we get, plug it into the other equation. So I'm going to choose the first equation and solve it for P sub 0. So I divided both sides of this equation by e to the k. Get 10,000 over e to the k equals P sub 0. Now we're just going to stick that in the other equation. 40,000 equals 10,000 over e to the 3k times e to the 5k. Simply replacing this with this. And now e to the 5k over e to the 3k, in division with the same base for both e's, we keep the base and subtract the exponents. 40,000 equals 10,000 e to the 2k is e to the 5k over e to the 3k is e to the 2k. Divide both sides by 10,000. 4 equals e to the 2k. Let's take the natural log of both sides. The natural log of the left side equals the natural log of the right side. Logs are used so that the exponent can go in front of the log. The natural log of 4 divided by 2 equals k. Divided both sides by 2. And what happened to the natural log of e? We can replace somewhere, anywhere we see k, we can put the natural log of 4. I think I'm going to put it in there. So 10,000 over e to the 3 times k, that means 3 times natural log of 4 over 2 equals P sub 0. Just replace this k with what we found right here. This is actually the answer to the question. The question is how many bacteria present initially. P sub 0, that means the initial population, is this right here. If this were the AP exam, I could just leave you an answer like that. But it's cool to simplify this because I can write this denominator as e to the natural log of 4 in parentheses with this 3 over 2 pulled out here. These are the same because when you have the e with these two exponents, it equals e right up there with these two exponents multiplied. And I know what e to the natural log of 4 is. You know that e to the natural log of 4 is just 4. And you know that 4 to the 3 halves is 8. Because the exponent is 3 halves, that means the square root of 4 raised to the third power. Square root of 4 is 2, and 2 to the third power is 8. And 10,000 divided by 8 is 1250. So 1250 equals P sub 0. That represents the initial population or number of bacteria present initially. So this problem can be done totally without a calculator. Right? There's no place where I used a calculator. You might want to use it for doing this division. Nowhere else though. Alright, on page 361, exercise 2, derivative of y with respect to x equals negative x over y. Y equals 3 when x equals 4. And we are told to use separation of variables to solve the initial value problem. This is called a differential equation because it has a derivative. We're going to start by cross multiplying. Multiply across y times dy equals negative x times dx. That we just got by cross multiplying, and now we're going to integrate both sides. The integral of y dy is y squared over 2. Copy the equals, copy the negative. The integral of x dx is x squared over 2. Don't forget to write plus c on one side or the other, not both sides. Time for initial condition. The y gets replaced with 3, and the x gets replaced with 4. This x is being squared, not this negative sign over here. 9 halves equals negative, not squaring the negative, 16 over 2 plus c. Add 16 halves to both sides. Nine halves plus 16 halves is 25 halves. Now we're going to put this where it belongs, right there. So that's y squared over 2 equals negative x squared over 2 plus 25 over 2. Remember the goal for solving a differential equation. The goal is to solve for this variable to equal a function of this variable. That's our goal. So from here we're just going to solve this for y. Multiply both sides by 2. Take the square root of both sides. Y equals plus or minus the square root of 25 minus x squared. Switch the order. This cannot be the answer because this is not a function. For a function for every x there has to be only one y. And we need y to be 3 when x is 4. Y has to be positive 3 when x is 4. That means the solution is y equals the positive square root of 25 minus x squared. In the directions it says indicate the domain over which the solution is valid. The graph of this would be a semicircle because of here x squared plus y squared equals 25 is an entire circle. Y equals just the positive square root, which is just the top of this circle with center 0, 0, radius 5. So domain means the x's, and all the x's on here are between negative 5 and 5. So the solution to the differential equation is y equals radical 25 minus x squared. This is a picture. Indicate the domain. That's that. Number 8. Derivative of y with respect to x equals e to the x minus y. Initial condition, y equals 2 when x equals 0. Well, the trick to getting started here is to know that e to the x minus y is the same as e to the x over e to the y. In division with like bases, we keep the base, that's up here, and subtract the exponents. Now, just like with the previous, we're going to cross multiply. Cross this way, it's e to the y, dy, equals, diagonally this way, e to the x dx. Time to integrate both sides. The integral of e to the y dy equals the integral of the other side, integral of e to the x dx. I know the integral of e to the y dy is e to the y plus c. The integral of e to the x dx is e to the x plus c. We need a plus c on one side or the other. Initial condition, y is 2 when x is 0. Y is 2 when x is 0. That means e squared equals 1 plus c. So e squared minus 1 equals c. And then we're going to just take this, what c equals, and stick it up in there. So e to the y equals e to the x plus e squared minus 1. I'm just saying where this, in the spot where the c is, we're putting that. But we do need to end up with y equals a function of x. That's the goal. This y at the top has to end up equaling a function of x that's on the bottom. And we don't have that yet. So we are going to take the natural log of both sides. The natural log of the left side equals the natural log of e to the x plus e squared minus 1. Because natural log of e to the y, we can put the y in front. But the y is in front of the natural log of e. You know what the natural log of e is? I think we're done. Y equals, y all by itself equals a function of x. Y equals the natural log of e to the x plus e squared minus 1. We'll talk about the domain in class number 10. The derivative of y with respect to x equals 4 radical y natural log x over x, differential equation. Initial condition, y equals 1 when x equals e. So when we did these earlier in a video called Differential Equations Introduction, we multiplied both sides by dx. And then in the introductory video, we would just integrate both sides. We are not allowed to integrate both sides unless the variables are separated. We have to separate the variables. That means on one side of the equal sign, there has to be only y's. That's okay here, d is not a variable. On the other side, there has to be only x's. So we have trouble here because we have y's and x's, y and x on the same side of the equal sign. So we must divide both sides by the square root of y, so that the square root of y on this side will be gone. So separate the variables means only x's on one side, x's, no y's at all. Only y's on the other side, there's no x's. Also, no d anything in the denominator. No dx, dy, d anything, dt in a denominator. Not allowed. So we do not have a dy or a dx in a denominator anywhere. So that means we're ready to integrate both sides. 4 can go to the left as the integral sign. And I do believe I copied something wrong here. We got this x, so we're going to sneak it in there. Sorry. So let's go back up here. This is the original differential equation. We multiplied both sides by dx. And then we have this issue of having y and x on the same side. So we divided both sides by radical y. Okay. And then we say we're ready to integrate both sides. So the left side is the integral of y to the negative 1/2 dy. The right side is 4 integral natural log of x times 1 over x dx. Dividing by x is the same as multiplying by 1 over x. The left side is straightforward. The integral of y to this number dy is y to this number plus 1 over the same thing, 1/2, plus c. Not writing plus c. Copy equals copy 4. We need integration by substitution on this side. We'll let u equal the natural log of x. That's why we broke that out like that. Because the derivative of the natural log of x is 1 over x dx. This side is the integral of u du. Because I called this u right there. And all this is du. And I know the integral of u du. Y to the 1/2 over 1/2 is the same as 2 times the square root of y, dividing by half. A fractional exponent means radical. Copy the 4. The integral of u du is u squared over 2 plus c. Got to have a plus c on one side or the other. So 2 radical y equals, well, here I have a 4 here and a 2 here, so that's just 2. And that u is actually the natural log of x. So there's u squared plus c. Initial condition. Y is 1 when x is e. Y is 1 when x is e. That's the initial condition. 2 times the square root of 1 is 2. The natural log of e is 1. 1 squared is 1. 1 times 2 is 2. And when we subtract 2 from both sides, this c was 0. That's going to go right in here. So I'm copying the equation where the arrow's coming from. It's 2 radical y equals 2 natural log of x. To avoid the parentheses here, I put the exponent there, plus c, well, plus c is 0. Got that there. And we're not done. We need to end up with y equals a function of x. So we're going to divide both sides by 2. It's important to know that 2 is not on the x. It is the natural log of x that's squared, not the x. There's only one more thing to do. We need y all by itself. So we square both sides. Here's the left side. Here's the right side, which I'm turning back into the other form. I just rewrote that. I'm saying square both sides. Because the square root of y squared is just y. The other side ends up being the natural log of x to the 4th. I think we're done. So on the AP exam, a question like this is ordinarily worth either 5 or 6 points. Usually 5 points, and it goes like this. I use blue to grade this. When the student correctly separates the variables, which was right here, x is on one side, no y's, y's on the other side, no x's. and no dx or dy in any denominator, that's a point that's correctly here. So it doesn't matter how many steps it takes you to get there, you get 1 point there. If you correctly find the antiderivative of each, you get 1 point each, usually. So the correct antiderivative of this side, which was, this is where that's correct, you get a point. The correct antiderivative of the other side, which wasn't until way down here, some work to get there, is worth a point. And remembering to write plus C, which I guess you earned that point right there, is worth 1 point. Finding the correct value of C is worth that point. And you find this value of C using the initial condition. So far we've got 1, 2, 3, 4, 5. Need 1 more point for having the correct answer. And the thing about the credits here is they don't usually build. They don't build up. And partial credit is hard to get here because when the student does not earn the first point, the result is usually 0. No points at all. So the separating variables is crucial. If this isn't done correctly, you're going to get no points for anything else that's written. So grading this one, the variables were separated, not here. See D in the denominator. Right here, variables separated correctly. Correct integrals, sometimes they're worth 1 each, but in this case these are both exactly the same, so you probably would only get 1 point total for having both of those antiderivatives correct. Remembering to write plus C, 1 point. The problem is if you forget to write plus C, there's no way you can get any of the rest of the points. So you can get 1 point, 1 point, forget to write plus C, that's all you get, 2 total. You could write a lot of other stuff, it's going to be worth nothing. So then we correctly find whatever C is, find it correctly, that's a point. And then final answer point. So this one would be worth 5 points because the 2 integrals were identical. And both pretty easy actually. So 1, 2, 3, 4, 5. These are very easy to grade. And we're done for now.